Hello. So today is Friday. I'm going to do a demonstration, a demo with the Kubernetes without Kube-proxy. So we all know that the Kube-proxy provided the network connectivity to Kubernetes. Kube-proxy use IP table in kernel to provide the pod services and the pod connectivity. But in this demo, I'm going to use synonym project to replace the Kube-proxy. As you know, the Kube-proxy use IP table, and the IP table is a like decade of a legacy technology, and but synonym instead use eBPF, the new kernel eBPF technology to provide not only networking to Kubernetes, but also provide observability and security policies for network in Kubernetes. So this is the synonym project is a very advanced technology in the kernel to use the kernel eBPF. So I'm going to do a demonstration like run Kubernetes without Kube-proxy. So this is their documentation, and basically I follow their documentation to run the demo. So here is my demo diagram. I have a three Kubernetes node. One is control plane node, and two worker node. Okay, so each node runs a synonym agent that will populate the network connectivity between all the three nodes. So this is the steps I summarized in my lab. And basically, I use kubeadm to initialize my Kubernetes cluster. So I start a fresh Kubernetes cluster. And then the step two, I'm going to use a helm to create a template YAML file. Then I'm going to apply the synonym template YAML file to deploy the synonym. Okay. So, and step three, I'm going to join two other worker node to the control master node. And step four, I'm going to apply a connectivity test, which is deploy multiple pod in the worker node. So the worker node can talk to each other to test the synonym network connectivity. Okay, so basically just 4 steps here. And now let's go to our lab machine. So this is the control plane master node. I name it synonym demo 1. And this is a worker node, demo 2, synonym demo 2. This is the second worker node, synonym demo 3. So 3 node machine. So right now I have nothing deployed. So the Kubernetes, there's no cluster, Kubernetes cluster running, nothing here. So I'm going to follow the steps I listed here. To initialize the Kubernetes cluster, okay? On my control node. Initialize the, notice this setting is skip the Kube-proxy, okay? So when I started the Kubernetes cluster, there is no Kube-proxy running. And also pay attention to this dash v equal 5. So this is for verbose login for the kubeadm, so you can have more information. Okay, let's start to initialize the Kubernetes cluster. As you can see, there are some kubeadm initialized logs on this screen. So waiting for kubelet to boot up. This can take up 4 minutes. So when I run this verbose logging, you have more information on what kubeadm is doing, like find the load IP address. So there are some check some utilities. Okay. So now the Kubernetes cluster is initialized and started. And basically we needed to, run this command so we can access use kubectl to access the cluster. And also remember this kubeadm join. So that's the token we needed to copy and save. So we can, when we join the worker node, we can use this. Let's save here. Save here. So that's our token. Save it here. So now we can check. Okay, we need to copy this admin.conf file, so we can use kubectl to access our cluster. So let's check our what pod is running, right? In the Kube system namespace. As you can see here, we have a Kube API server running, Kube controller manager running, Kube scheduler running. We also have core DNS, 2 core DNS pod, but they are in container creating status. The reason is that we don't have we have not applied like CNI like final, so we cannot start a pod without a CNI plugin deployed. And by the way, the synonym also provided the CNI plugin capability. So to replace Flannel CNI plugin. Okay. Yeah, we don't see Kube-proxy, right? Usually we should see a Kube-proxy pod, but we don't see Kube-proxy pod here. Okay, so this is one node. That's our node IP. That's our node name. Okay, just one single node now. Okay, so no Kube-proxy, and now we got. I'm going to apply the synonym template YAML file that I created. Use the helm. So just remember here, this setting is kubeProxyReplacement strict, which is to replace the kubeproxy. And also this is our master node API server host IP address. This is our API server port, and then create to a synonym template YAML file. Then we're going to apply this YAML file and to deploy the synonym. Okay. So this is our synonym. I can show you more here. So this is the template we created. And what the most interesting part is the config map. So you can customize your synonym deployment through the config map. Where is the config map here? Okay, so this is the config map. So if you have any setting you want to enable or disable for the synonym agent, you can do here in the template YAML file. So it's a config map. The name is a synonym config. And so this is the settings. If you want to enable debug, you can set it to true. And so we want to enable IPv4 addressing. So you can also enable IPv6. And yeah, so that's the synonym agent configuration setting you can enable or disable. So it also has a tunnel mode. So by default, it's a VXLAN. So it's automatically set up. And you can also enable L7 proxy for L7 policy enforcement. Okay. And so here is the kubeProxyReplacement. We set it to strict, which is replace the kubeproxy. Okay, so there is also some health checking here. I disabled because the health checking, it will health check the node. So I disabled it to reduce the traffic noise. Okay, so there are a lot of stuff you can customize here. And just show you an example. Now we can apply this synonym. So after I apply this synonym YAML file, we should have a synonym agent running in this master node. Okay. So deployed the config map, synonym config, and the daemon set is to launch the synonym agent part. There is also a synonym operator container part in the part, container part. Okay, so now let's see if the pod is started up. Give it a label, app, synonym, kubecater, oh, get a pod. Okay, so now there is a synonym agent running in the master node. Okay, and so it's so as you know, once we deployed the synonym agent part, and then on the master node, and all the CNI plugin network and should start to work, and then we should see the core DNS running now, because the synonym provided this as CNI function. So our core DNS is running now, right? So everything looks good. Now let's do the next step. So we deployed the synonym agent. Now let's join the two worker node here. Okay. So let's start up join startup as worker node. We can run this at the same time. So this is worker node demo 2, worker node demo 3. So okay, it looks both joined fine. Let's check our load. So we should have a 3 node here ready, and this is worker node demo 2, worker node demo 3, both ready. Okay, that's the node IP. And also, so the synonym agent will automatically deploy on each node, and we can check that. Okay. All right. So another two synonym agent pod running on the worker node, right? So the synonym is deployed on both worker nodes. Now we can create a test namespace to deploy the collectivity pod. Okay. And let's apply the collectivity pod. So there are quite a few pods get created on each worker node, and then and services to test the connectivity between and the pods, and from pod to services. Okay, so based on this diagram here, so by default, the synonym set up the VXLAN network between each node. And so we have pod deployed on worker node. And let's check the connectivity. We can run TCP down on the physical network interface because it's going through the VXLAN. The VXLAN overlay network runs on top of the physical network. And if we run on the physical network interface on the node on port 8472, which is a VXLAN port, we should see some traffic. Okay, so let's run on TCP down on the worker node. S3, that's our physical network interface. We want to capture the VXLAN traffic, overlay traffic. Okay, so we see some traffic here, and between pod. So we can run a capture. Just look at it in Wireshark. Let's really. And VXLAN cap. Let's copy to our VXLAN cap. So okay, enough time. We capture some packet, and then let's cut to our local machine, and then we can look at the capture file. So this is our capture. And as you can see here, seems all the stuff is working. TCP, DNS query, right? So if we look at one collection here, let's just check this collection, follow TCP screen. So it's sent a GET request, got a response. Okay, so the network is working. Let's look at the SIM packet, the three-way handshake packet. So this is VXLAN header, and notice this is a VNI identifier. That's the VNI ID for the VXLAN network. And pay attention to this 61859. So this is from pod 10.0.1.214. So in Sydney, each pod has a identity ID. So then in the VXLAN network, the pod identity ID is used in the VXLAN network identifier. So this is from this pod 214 to pod 169. Right? And so this is SYNAC. The SYNAC, notice here, it has VNI 7987. So that's the identity number for pod 10.0 to 169. And okay, so this is a little bit more information. We can discuss this later. Anyway, so it looks like it is working, and this is our VXLAN. This is our the encapsulated pod IP here. Encapsulate the pod IP between different worker node. Okay, and so this is our Kubernetes worker node IP. Okay, that's the outer IP header. All right, so looks everything is working and straightforward. So that's my first impression about signaling. And later we probably can talk more about the technology signaling use, the eBPF in the kernel. That's very advanced technology. And so I just started to learn signaling, and I'm able to set up this lab just with a few steps. And that's a pretty cool project.